We're going to talk about Newton's law, third law of motion and momentum. Okay, and don't let that term scare you. It's a pretty simple concept. Look right here. Newton's third law of motion, unlike the first and second, pertains to force between two objects. Okay? Okay, so for example, when you kick a soccer ball, do you feel the force of the ball against your foot?
Yeah.
You do. Well, does the ball feel the force of your foot? I don't know. Well, Newton's law explains this occurrence. Okay, so look right here. So, have you ever jumped off of a skateboard? Anybody got a skateboard? Anybody skateboard in here? Nobody skateboards? Okay, I used to have a student who was like a champion skateboarder. His picture was actually on a one of those skateboard magazines once.
Mm-hmm.
Okay, so it says right here, have you ever jumped off a skateboard? Well, what happens to the board when you jump off? Look here. What happens to the board when you jump off of it? What does it do?
Slip.
It goes the opposite way, doesn't it? Usually. If you go in this direction, your skateboard will go in that direction, unless you get off of unless you stop it completely.
Yeah, and then get off of it.
But if you just jump off of it while it's moving, it's going to go the other way. It's going to go the opposite way that you're going, right?
Mhm.
So, this is Newton's third law of motion at work. You applied a force to the board, and the board applied an equal and opposite force on you. Okay, equal and opposite. So we call these action-reaction forces. So here's the law. Here's the law in a nutshell. For every action, there's a reaction. Okay, a simple concept, right? For every action, there's a reaction. And always think of this guy jumping off of his board. He's going one way. The skateboard's going the other way. That'd be an easy way to remember what that law is. Okay? Here's our first question right here. You ready? Everybody ready? When you sit on a chair, the seat of the chair pushes up on you with more force than your weight. Is that true or false? Mark an answer. It's okay to be wrong. It's not the end of the world. Mark an answer.
When you slip on it.
When you sit on a chair, the seat of the chair pushes up on you with more force than your weight. Is that true or false? Okay, now listen. Let me show you something here. Look, what did we just say about this law right here? Equal. Equal and opposite. Equal. Okay, is equal are you gonna get more than if it's equal? Huh? Are you gonna get more than if it's equal? No, you're not, right? So let's look at this question here again. So how would you answer that question? When you sit on a chair, the seat of the chair pushes up on you with more force than your weight. Is that a true statement or a false statement?
Like, what do they mean by that? When you sit on
Well,
it,
is it equal or and opposite? The law says it has to be equal and opposite. Is more equal? Huh? Is more if something's more, is that equal? Okay, good. So what's the answer? Mark your answer. Okay, so look right here. So action-reaction forces are always found in pairs that are equal and opposite. Based on what we just said here. Look what we just said here. Look, let's look at what we just said. Newton's third law at work. You applied a force to the board and the board applied an equal and opposite force on you. And we call these action-reaction forces, and that's a law. For every action, there is an equal and opposite reaction. Equal and opposite being the key words, right? Equal.
Mm-hmm.
Okay, so let's look at this again. Okay, so action-reaction forces are always found in pairs that are equal and opposite. Is that a true statement or a false statement? Mark your answer. That's a pretty simple answer, right? Makes sense? Okay, based on what we just read there, just those two paragraphs. Okay, so now let's look. Let's look right here. Force always exists in pairs. Always exist in pairs. What did I say? Always exist in pairs. Based on it, and that was the question that we just answered, right? So forces always exist in pair. Newton's third law defines these action and reaction forces. Look right here. You guys, anybody have these balls at home?
No, I never understand how they work.
Well, for every action, look here. here's the action right there, boom, and there's the opposite reaction. Look here, action, action, reaction.
But.
Action, reaction, look, action, reaction, action, reaction. That's a law, always exist in pairs.
So those three will not move?
So you could take these two right here, and these other two will move. It's gonna be in pairs, in twos, okay? Okay, so let's go back to the soccer ball idea. Jaleel,
Yes.
Michael, you with me?
I'm listening, I'm looking at it.
As you kick the soccer ball, you apply an action force to the ball. And the ball applies a reaction force on your foot. Okay? These forces are equal in strength and opposite in direction. Why does the ball accelerate more quickly than your foot? Well, let's just see if we can answer that question here. Well, to do that, I would have to do that. We'll answer that later. Okay, let's move on here. Okay, look right here. Here's some action-reaction stuff going on. So the third law states that for every action force, there's an equal but opposite reaction force. Okay? Looks like they're pushing forward, right? Back, forward, back, right? So this means if one object applies a force to another object, then the other object exerts an equal and opposite force on the first object. Okay, here we go. Let's look at this again. Okay, here's our next question here. When you jump off of a skateboard, which of the following is true? You accelerate more than the skateboard. Anytime you see the word more, that's not right? Because it's got to be equal, and equal is not more. Okay, you and the skateboard accelerate equal, but the opposite amounts. The skateboard accelerates more than you. So which one of those is the correct answer? A, B, or C? Mark your answer. Everybody should get that one, because if you see the word more, it can't be the right answer, because Newton's law says for every action there's an equal but opposite reaction, okay? And equal is not more, okay? Makes sense? You got an answer there, Jaleel? Jaleel,
Yes.
okay? Good. Let's go to the next one. Okay, let's look right here. Ooh, anybody want to do this for a living? Okay, so according to Newton's third law, the cart pulls on the man just as hard as the man pulls on the cart. The cart pulls on the man just as hard as the man pulls on the cart. Do these forces cancel each other out, preventing the cart and man from moving? No, he moves, right? Okay. Okay, look right here. So here it is right here. Woo! He's pulling, and this thing is pulling backwards. But he's an unbalanced force though, right? He's got more, go back to that first law, an unbalanced force. Okay, so the man applies force to the cart that moves the cart forward. The reaction, the cart applies an equal and opposite force on the man. Well, each force in the pair acts on a different object. Okay, so the cart applies an equal and opposite force on the man, just as the man applies the equal and opposite force on the cart. Okay, so let's look right here. If a force occurs, there are action-reaction forces. So here they are. Action-reaction forces, look right here. They can cause changes in motion. They're equal in strength but opposite in direction, and they act on different objects. Okay, that's three principles there. They can cause change in motion. They're equal in strength but opposite in direction. Think of that skateboard, and the man jumping off of it, or the girl, whoever's on the skateboard, and act on different objects. Ready for another question? Here we go. So which of the following statements pertain to the third law of motion? Okay. Action and reaction pairs always act on the same object. Okay. Mass is indirectly proportional to acceleration. An object at rest will remain at rest unless acted on by an unbalanced force. Now, that's the first law, so you can't even choose C. So we're down to A, B, and D, A, B, or D. If a force occurs, action and reaction forces are present. Which one of those is true? Mark your answer. A, B, or D? Actually, you can't choose A. Choose B or D. B or D. Okay, got an answer? Okay, here we go. Okay, look right here. Textbook is resting on the table. Tommy pushes the book rightwards. What's an action-reaction pair in this scenario? The book exerts a downward force on the table. The table exerts an upward upward on Tommy. Tommy exerts a rightward force on the book. The book exerts a downward force on the table. Tommy exerts a leftward force. The book exerts a leftward force on Tommy. Tommy exerts a rightward force on the book. Okay, now he's going right? Okay, so Tommy exerts a downward force on the table. The table exerts a rightward force on Tommy. Which one of those makes the most sense? I'll just tell you this, if it has down in it, you can't choose it. So that leaves B and C, right? So which one of those makes the most sense based on what we just talked about the action-reaction, equal and opposite? Which one of those is equal and opposite, B or C? Mark your answer. Which one is equal and opposite? Got an answer, Jaleel?
Yeah, I already answered.
Good job. Michael, got an answer? Got an answer, Terry? Good job. Got an answer there, Juwan? Juwan, got an answer, B or C? Mark an answer.
I get that.
Okay, action-reaction pairs cancel each other out since they are equal and opposite to each other. Is that a true statement or a false statement? Mark your answer. Okay, I'm gonna move on. Let's see here, how much time we have left here. Okay, we're gonna stop right there. We're gonna stop right there, we'll talk about momentum. Let's see here, we'll talk about momentum, the next time, okay? The next time we meet. Now, for those of you at home, we're recording this lesson on Monday, the 26th, and the weather forecast is for possibly dangerous roads, so our lesson will be in Study Island tomorrow. So if you are at home, tomorrow you go into Study Island, and there will be a lesson, I believe it's going to be entitled Force and Motion. You're going to do that lesson, okay? And the way to get into Study Island is go into Clever, sign in with your Google account, and then you'll find Study Island there, and go into the lesson, okay? All right, so we're going to stop this lesson here for the day.
Do I close this?